All right, welcome back to the next edition of your online geometry course. We are doing 1.7 today. Don't worry about the fact that there is no video for 1.6. We actually cover that section later on in the year. Fits better somewhere else. So let's go ahead and jump into this. The vocabulary says length of a line segment. You guys probably remember that we discussed line segments, and if you wanted to talk about the actual figure, you said AB with a little line segment on top. Mathematicians, being crazy, lazy, and efficient, they just write down AB without the line segment if they're talking about the length of the line segment. All right. So if we are defining the length of the line segment, if you look back at your notes, we wrote down it is the distance between the endpoints. So that leads right into what we're going to be doing today. The lesson name is going to be the distance and midpoint formula. Ta-da. Here we go. Okay, the distance formula. The distance d between 2 points, A, which is x1, y1, and B, which is x2, y2, is, what I'm going to do here is I want to make sure you guys understand what this is saying. This used to freak me out because they looked like exponents. I remember when I took algebra, I saw x1 and I was like, oh, what is that? That's just saying the x coordinate from the first point. That is the y coordinate from the first point. That's the x coordinate from the second point and the y coordinate from the second point. So the formula for the distance formula, or the distance formula, is the square root of x2 minus x1 squared plus y2 minus y1 squared. That is what it is. Distance equals that. I know you guys learned the Pythagorean theorem, and what you will find is that the Pythagorean theorem is the same thing as the distance formula, and it's actually the same thing as the equation of a circle, and we'll learn that later on in the year. But I want to show you how this works. We had two different points here. Let's say we had this point right here, and we had this point over here. If you want to find the distance between points, if it's just a vertical change, that's easy. You just count your tick marks. If it's just a horizontal change, if the points were side by side, you could just count the tick marks. When it gets difficult is when you have something that is diagonally like this. So what we could do here is we can call this one right here x from the second, comma y from the second, and this one over here would be x from the first, y from the first. Okay? So when we are looking at that, it's still confusing what we're going to do. Well, we can go over and make this into a right triangle. Why is that helpful? Well, over here is the vertical change. The vertical change is the change of which axis? Which coordinate? Y. So we could just say that that length is represented by y2 minus y1. Take the y from your second point and subtract the y from your first, and you'll find out at this length. This right here is the change of x. That's x from the second point minus x from the first point. Where are we going to go with this? Well, we're going to use the Pythagorean theorem. Pythagorean theorem says a squared plus b squared equals c squared. Okay? A squared plus b squared equals c squared. Well, what is a squared? A, let's call it this one right here. That is x2 minus x1 squared plus, what's the other one? y2 minus y1 squared. And that is going to equal the hypotenuse squared, which is, we're just calling that distance squared. Okay? Well, how can I get the distance by itself? I want the distance, not distance squared. Square root and square root. And now do you see the formula? Cool. All right. Well, now that you have that, I want to give you a little way that you can remember it. I call it the karate rabbit because I always forget if there's a minus in here, a minus, a plus, forget the square roots. I call it the little karate rabbit. So your little karate rabbit has a bandana on, has little eyes, cute little button nose, little eyebrows, and then there's your rabbit. Karate rabbit. Look at that karate rabbit. So now if you're trying to figure out what goes inside here, remember he's got little eyes in there. Don't forget about his eyebrows. He has a button nose. Little rabbits have little button noses, so I call it the karate rabbit. Karate rabbit should help you remember the formula. x2 minus x1, y2 minus y1, and so on. So let's go ahead and do some problems. I'm going to, I don't want to actually white out. Let's see, white out that, white out this. Okay, now let's go ahead and do an actual problem. It does not matter point 1 and point 2. It's just like finding slope. Let's call this point 1, x1, y1. Call that point 2, x2, y2. Okay, so on here, you just set it up. Square root of, what is x from the second point? -3. Minus, what is x from the first point? 2. Squared. Minus, what is y from the second point? 10. Minus, what is y from the first point? 9. Squared. And then you just simplify. Square root of -3 minus 5, or minus 2 is -5. Squared. Minus, actually, sorry, button nose, plus. And then we have 10 minus 9 is 1 squared. That's the square root of 25 plus 1, which is the square root of 26. That is the length right there. Okay. Alrighty. If you got to a standardized test 2 or 3 years from now and you forget this formula and you forget the karate rabbit, you could go over and plot these points. So you would plot the point, plot the other point, make a triangle, see the vertical change, see the horizontal change, and use the Pythagorean theorem. Most people remember the Pythagorean theorem, but a lot of them forget this right here. Even I put a minus here at first, and then I remembered button nose. Okay, let's make sure we did this right. So y2 minus y1 squared plus, x2 minus x1 squared plus y2 minus y1 squared. And you get this. That gives you -5. Make sure if you put -5 squared in your calculator and don't use parentheses, it's going to tell you it's -25, and that throws everything off. So just be very careful. Let's go ahead and do some more problems. So I'll do one more, and then I'm going to have you do one. Let's call this, always go over and note it. X1, Y1, X2, Y2, X1, Y1, X2, Y2. It'll just keep you from messing things up. So that is the square root of 2 minus 6 squared plus, what is y2? -4 minus y1, 6 squared. That's -4 squared plus -10 squared, square root of, don't put that in the calculator without parentheses, 16 plus, don't put that in your calculator without parentheses, 100. That would give you square root of 116. You could put that in your calculator and get a decimal, or you could go over and simplify it. Simplifying it we'll cover a little bit later, but it's basically where you have 116, you divide by 2, that would give you 58, which is divisible by 2, which is, Mrs. Goodman may have done this different also. 25 plus 4 is 29. I believe 29 is prime, so it'd be, once again, we'll go over this later. I'm okay if you go over and give me an answer like this, or if you put it in your calculator. So I want you guys to try now is one of these problems. Yours. Let's say you had the point 1, 3, and then you had the point -2, 7. Go ahead and find out the distance between these 2 points using the distance formula. Okay, so you should have done x1, y1, x2, y2, square root of -2 minus 1 squared plus 7 minus 3 squared. That is the square root of -3 squared plus 4 squared, square root of 9 plus 16, square root of 25, and that gives you a nice pretty 5. Hopefully you guys got 5. All right, next. So if you had a problem like this and it says Louisa takes the subway from Oak Station to Jackson Station each morning. Oak Station is 1 mile west and 2 miles south of Plaza. Jackson Station is 2 miles east and 4 miles north of Plaza. Think of City Plaza 00. Use the distance formula. Okay. Well, I'm going to show you this, but I'm actually going to do the Pythagorean theorem just to show you how it works. So Oak Station is 1 mile west, and 2 miles south. That's here. The next one is 2 miles east and 4 miles north. 2 miles east, 4 miles north. Could you use the distance formula with these 2 points? Yes, but you could also go like this. This is a change of 1, 2, 3. Change of 3. This is a change of 1, 2, 3, 4, 5, 6. And we could just do 3 squared plus 6 squared equals d squared, or c squared. That gives you 9 plus 16 equals, I'm calling it distance, d squared. Let's see, that gives you 25 equals d squared, and then you square root. Something feels fishy here, and that is this. I wish you guys were here to yell at me. What is 6 squared? Is it 16? No, 6 squared is 36. And then that will give you 45. You'd square root. That's your answer. So people say, well, why wouldn't we do this all the time? The distance formula is a nightmare. Well, what happens if you had these points? 100, comma, negative 343, and 572, comma, 983, negative. Would you want to plot those and make a triangle? No, you would not. You'd want to use the formula. Okay, so once again, it's over by 1, 2, 3, up by 1, 2, 3, 4, 5, 6, so you can use the Pythagorean theorem. Or we could have done the distance formula with the point. Let's see, negative 1, comma, negative 2, and the other point is 2, comma, 4. I will do it really quickly. Just look at it. x1, y1, x2, y2. Let's make sure we get the same answer. Square root of 2 minus negative 1 squared, be careful with minus negatives, plus 4 minus negative 2 squared, square root of 3 squared, plus, is that 2? That's a 2, plus 6 squared, square root of 9 plus 36, and you get the same answer. Lovely. All right, let's move on to midpoint now. Page. Next page. Okay. Every time I go to a new page, I have to change my font, which is very annoying, but you have to deal with it also, so sorry. All right, here we go. So, mid-segment. Midpoint of a segment. The midpoint of a segment we already defined. It is a point that divides a segment into two congruent, symbol for congruent, segments. So we talked about midpoint. Now we're going to be looking at midpoint on the coordinate plane. All right. The midpoint, try not to think of this as a formula. Try to just think about it conceptually. Going from, if you have one x coordinate and another x coordinate, the midpoint will just be the average of the two. If you have a y coordinate and another y coordinate, the y coordinate of the midpoint is just the average of the two. So you can remember this. as x1 plus x2 divided by 2, y1 plus y2 divided by 2, or you can just think of it as averaging your x's, averaging your y's. Why is that better? Because people are going to accidentally put a minus there instead of a plus. So if you had this 6, 6, and 2, -4, and we wanted to know the midpoint, here's one of my x's, here's the other x. Let's average them. 6 plus 2 divided by 2. That's going to be your x coordinate. Here's a y, there's a y. Let's add them together and divide by 2. Average them. So you get 4 comma, that gives me negative, or that gives me 2 over 2, so it's 1. Okay, 4 comma 1. That's going to be the midpoint. Lovely. Midpoint formula makes sense? Hopefully. Okay, now sometimes it can get a little confusing, and they give you the midpoint, and they give you one of the endpoints, and you need to know what the other one is. This is how I do it. Let's pretend like we couldn't even see this, because if we can see it, it's an easy problem. Let's pretend like we couldn't see this. Do you agree that if you had a point in the midpoint, the change, vertical change to get to your midpoint will be the same exact vertical change that you will get to your other endpoint? The horizontal change to the midpoint will be the same as the horizontal change getting to the other point, because it's half of the total change. So watch this. If midpoint of AC is M, which is here, and that is the endpoint, what's the other one? Well, we are going from 1, 6 to 3, 4 at the midpoint, and now we got to do the same exact thing to get to the other endpoint. How do you get from a 1 to a 3? Do you add or subtract? I went up by 2. So going from the midpoint, what am I going to do? Add 2. And now we are at 5. Going from 6 to 4, what do you do? Subtract 2. So what do we need to do again? Subtract 2. That gives me 2. Once again, we had a point, 1, 6. 1, 6 is roughly here. Then we had a point, 3, 4. 3, 4 is roughly here. So you had to 1, 6. Okay, so what ended up happening was this was a change of 2. So going from here over, we're going to do another change of 2. So your point is going to be somewhere around here. Then you went down by 2, so you're going to have to go down by 2 again, and that's this concept right here. Whatever you did to x to get your midpoint, do the same thing. Now, yeah, that's the easiest way to do it. You can also do this. You can say 1 plus some number, the other x coordinate divided by 2 is going to give me the x coordinate of my midpoint. 6 plus some y coordinate divided by 2 is going to give me the y coordinate of my midpoint. And you could solve this. When you solve this, you would end up with multiply by 2, subtract 1, 5. Multiply by 2, 8, subtract 6, and you get 2. You can do it with a formula, or you can do just reasoning. I'm cool with either way. Okay. This is going to be a shorter lesson than the others. Get to the next page, and then we shall almost be done. All right, here we go. Options, stroke 1. Okay, so now it says the line segment AB has J its midpoint going from A to J. Is that what is the location of B? Let's see if you guys can follow this. Do either the method where you write out the formula using the midpoint, but you're just missing one of your x's and y's, or do it the way I did it. Pause the video, do it. Okay, Going from 1 to 7, what do? Add 6. What do I have to do again? Add 6, and we end up at 13. 5 to negative 7 is going down by 12, so if we go down by 12 again, is going to be what? Negative 19. Did you get 13, negative 19? Hope so. Okay, now we are going to start doing just a few harder problems. GH has a midpoint at R. If we have the following locations and RH is 2x plus 1, then what does x equal? This is a challenge problem. So GH has a midpoint. GH has a midpoint of R. I'm going to draw it. G is at 1, 3. R is at 4, 7. And RH is 2x plus 1. You start asking yourself, do we have two parts and we could set it equal to the whole? Do we know two things are congruent, so we're able to set them equal to one another? Their measures? Oh, if this is a midpoint, then that must be congruent to that. So if I just knew what this length was, I could set it equal to 2x plus 1. Well, is there any way to find out what this length is? Yep, distance formula. So let's quickly do that. x1, y1, x2, y2. You have the square root of 4 minus 1 squared plus 7 minus 3 squared, square root of 3 squared plus 4 squared, square root of 9 plus 16, square root of 25 equals 5. So over here actually equals 5. So what do we need to do? Add them together and set equal to the whole. 5 plus 2x plus 1 equals no, because we don't know the whole. We know that this is congruent to that, so we can say 5 equals 2x plus 1. So 2x equals, subtract 1, 4. 2 equals x. Okay, lovely. Almost done. Okay, the next one, JK has a midpoint of M. M has a midpoint of A. Determine the location of A. I think we should draw it out. JK has a midpoint of M. Okay, so good so far? MK has a midpoint of A. So technically, these are congruent now. This and this are congruent. Determine the location of A if J at 2, 1 and K is at 12, 7. How am I going to do this? Can we jump straight to knowing what A is? Nope, we need to know what M is first. So let's find the midpoint. Midpoint is add together the x's, 14, divide by 2. Add together the y's, which is 8, divide by 2. So M is actually located at 7, 4. Okay, this is 7, 4, and this is that, and that's the midpoint. We could just do midpoint formula again. 12 plus 7 is 19 divided by 2. 4 plus 7 is going to be 11 divided by 2. And there's your answer. Okay. All right, we are finally at the last problem. No, we're not. We're going to skip this one, and we're going to go to this one right here. Okay. It says Flagstaff has decided to put a tightrope. Actually, you know what? Let's talk about this one in class because I think it's going to be more challenging, and I think it'd be good for us to talk about this one in class. Let's just do this one and be done. MN has a midpoint of N. MN has a midpoint of L. M is located at 0, 0, and N is located at AB. What is location? What is the distance between M and N, and what is location of this? Well, let's just use the midpoint formula. That is, add your x's together. What is 0 plus a? A. And divide by 2. Add your y's and divide by 2. 0 plus b is b, divided by 2. So this is the location, a over 2, comma b over 2. This is just seeing if you know how to work with variables. And if we wanted to do x2, y2, if we wanted to find distance formula, we would just use these as if they were numbers. Let's quickly do that. What is x2? A minus 0 squared plus, what is y2? B minus 0 squared. Square root of a squared plus b squared, and that's our final answer. Just making sure you guys know how to work with variables. All right, that's it. We'll talk about this one. It's kind of cool because we talk about how downtown is set up and whatnot, but let's do that in class. All righty, thanks for watching.